board. Oh, actually, let me just stop for a minute. Board. Okay, I'm going to show you what we're going to be working on today. So I want to share my screen and let me pull it up. Okay, so last week we talked about the engineering design process. Well, let me see, it just jumped up forward, sorry. So last week on Monday, October 18th, we talked about the engineering design process, and I introduced the design project we're going to be doing and talked in more detail about stage 1 and 3. And today, what we're going to be working on a week later, I reviewed all your submittals and I made a lot of comments on your submittals. So today, the first hour and 15 minutes, we're going to talk more about the design project and go over the submittals so that I want you first to introduce to everyone the project that you want to work on. And then I'm going to share comments on the submittal, and I'm going to have you guys read my comments, and then you could start editing those first 3 stages. And then at 3:45, we're going to talk about sustainability criteria, which is criteria we're going to add to our stage 3. And Karen Groppi in our engineering department is a resident expert on sustainability. So she's going to come in and present a topic to you. And then I'm going to give you some examples of what students used as sustainability criteria in previous Engineering 25 classes. And then from 4:45 to 5:30, we're going to be working on Submittal 2, and I'll have time to meet one-on-one with those of you who have questions. And then remember, at 5 o'clock, Keith is available for AutoCAD tutoring. All right, so let me stop sharing for a moment and see if there are any general questions before we begin. So any general questions? Let me just see who's here. So I'm going to go back to sharing my screen. So as a reminder, those of you who felt like, I did write a lot of comments on your submittal number 1. Some of you were a little off from what I was expecting. And I noticed that it was those of you who either left class early. So if you miss any part of class, you've got to watch the video. So on last week's class, we looked at what the engineering design process is all about. And the first item, the first submittal, included basically stage 1, 2, and 3 of the engineering design process. The first one was just a brief problem statement, and we just want to have 1 sentence describing what the problem you're trying to solve. And all of you did a good job on the problem statement, although I did probably make some of your statements a little smaller. So you'll notice that. You'll have time to look at my comments later, so please listen to what I'm saying now. Do not look at the comments right now. Stage 2, it's very important that both these stages are bulleted lists, because as engineers, we really want to see things and be able to read through things quickly. Or if you don't want to use bulleted lists, you could use headings for each item if there's a lot more detail. But remember, you are completely analyzing what the problem is. So some of you are designing desks in your office or in your room. Well, it would be important to see a sketch of what your room is. What is in there? What kind of space do you have? Because in order to design a desk for your room, you really need the people who are reading this really need to understand what size is that you're working with. Because if you didn't know the size of your room, you cannot design a table or a desk. So remember, you have to completely analyze this. And then for stage 3, I want a bulleted list of constraints. And remember that I did include some constraints in the project that are definite, and you have to include them as well. So we're going to come back to that in a little bit. So what I'm going to do is stop sharing in a student view. I'm not in student view, but I want to remind you again that the first statement has to be a simple statement. And then the problem analysis is all the details that define what the problem is. So many of you are talking about organizing things, and you need to give us a list of what space you have available and also what things you're trying to organize. And then we needed a bulleted list of the constraints. And I want to remind you what that is as well. If you go to our design project, let me open this up. And here's the design project. Let's open it up. Can everybody see the project? On the top, it says Engineering 25, Graphics and Design, Individual Design Project. Do you see that?
Yeah.
Yeah.
Okay. Okay. So let's just go down. It says all table designs will be required to meet the following minimum design specs. So the one, meet the stated need. So you're specifying what the need is, and dimensionally appropriate. So you're going to have to figure out what kind of space you need, which means knowing what space is available in the place that you want to build it. So for instance, with Gillian, if she wants to do something with a pot stand outside, a gardening pot stand, you're going to have to figure out, well, what area in your backyard do you have to be able to put this up? So you need to know what the spaces are. The design needs to support the typical loads. So you also need to write down what kind of loads you're dealing with. And it has to have 6 distinct parts. And if we go back to parts and products, remember we talked about that at the beginning of the semester? You might have something that's a product, and what you're going to be designing is a product. And I'm telling you that it has to have at least 6 distinct parts. And distinct meaning unique, different parts. And the reason why is because you're going to be producing working drawings for this project. So if you make a tabletop that has 4 legs and every leg is exactly the same, how many distinct parts do you have? Let me say it again. If you design a table that has a tabletop and 4 legs that are exactly the same, how many distinct parts is that?
2.
2. You need 6. And I also want to say screws and bolts and hinges, those do not count. And the reason why is you're going to be buying those pieces. You're not going to be fabricating. You're not going to need to do a drawing of that. Do you remember that from the beginning of the class? If you go to Ace Hardware and buy screws, you are not going to draw the top, the front, and the right side of a screw. You bought it. You're not going to have to build it. So when I say 6 distinct parts, I mean 6 different parts that are going to require drawings, which includes the orthographic drawings and the isometrics. Okay, you're going to talk about the different kinds of material you want. And also, I did set a budget of not to be more than $100. But if you're designing something like, for instance, Derek, what you're going to design with the auger and the backhoe, as long as you're willing to spend more than $100, well, then certainly you guys all could make the budget higher if you want. Okay, so these are some of the specs I have. Plus, we have a time constraint spec, right? The project is due to be presented on November 29th or 28th. So you know how many weeks you have. That is another constraint. So the first stage, let me close this. Let me move your photos again. So the first stage is a short sentence. The second stage, make it a bulleted list of all information about the problem. And then the last third stage is all about specifications. So, and remember with, let's look at that. Remember the dog project? We said the first stage was my dog is getting out of my backyard, which isn't enough information, but the reader knows what the problem is. The problem definition included all this stuff. I would have had to say, what is the breed of the dog? What is the size of the dog? What's the size of the backyard? What type of fence is it? How is the dog getting out? Is the digging spot always in one area, or is it in multiple areas? Where is the dog going? These are all the things that define the problem better. There are at least 10 items here, and you should have at least 10 items as well. And then in terms of solution constraints, we had money, we had the amount of material. We don't want to hurt the dog. We don't want to use toxic material. We only have 2 people to work on it. And when are they available? What I noticed when you guys did stage 2 and 3, you needed to provide me with more detail. So I'm going to stop sharing for now. And I am going to pause the recording. Okay, so I'm going to start recording. So is everybody with me now? Just put your editing stage 1, 2, and 3 on hold for a little bit. Everybody thumbs up? Everybody with me? Give me a thumbs up or yes or something. Okay, great. All right, I'm going to share my screen. And I'm going back to the design project, right? The design project. And as you go down, wait, I have to move your photos again out of the way. As you go down towards the bottom of the design of the sheet of the project, it says project requirements. And you notice that there's going to be a report. So there's going to be a title page that's going to have your name, whatever you want to call your project, and the date. And then you're going to have the problem statement, problem analysis, design specs, and continue going on. So basically what you're doing right now is you're starting to create your report. You're editing the first 3 stages, right? You're editing the first 3 stages, and we're going to put information in there about sustainability soon. Okay, I'm going to stop sharing. And stage 3 is design specifications or solution constraints. I probably should have given you a break. Why don't you just go take a 5-minute break before Karen gets on? Karen's going to be here about 3:45. Okay, well, I should introduce you then, Karen.
Yeah.
So Karen is one of our engineering faculty. She's been on the longest with me. So I started in 1995 teaching at Cabrillo, and Karen started in 1998. And I first met Karen when she was working as a civil engineer in downtown Santa Cruz. And I used to bring students to Karen to talk about what she's done in design, because she worked in engineering for over 18 years. And she and I have been running the program since 1998. And she's a resident expert on sustainability. So thanks, Karen, for coming to talk with us today.
All right. Thank you, JP. Yeah, I don't know if I'm an expert. I'm hoping, yeah, that we all need to sort of become experts in sustainability, because it's really, it's our future. And yes, I've taught engineering 25 about, I don't know, 40 times maybe. So I've taught it a lot of times. So I'm pretty familiar with the project and the table project. So it's a great opportunity to apply sustainable principles. So I am going to, let's see, I'm going to share my screen here. I have some slides. Oh, actually, let's try these slides. Sorry. Okay, can you see that?
Yes.
All right, here we go. So what is sustainability? Yeah, I can't really tell you that. So it's changing every day. So you have the honorable and important task of making your design sustainable. Everything we do has to change for sustainability now. Everything we have to do. If we fail to think about sustainability, it's like game over on the planet. So let's take a look. It's a moving target. It's what we all want. It's a future that continues to have a future. And so I'm going to share with you some principles today that will help you measure your decisions and your actions to see if they're taking you toward something that's sustainable, or if they're taking you away from that, or if they're, and there's different ways to measure it, depends on who you ask, right? So the scientists said this many years ago, and we haven't really paid attention to it, so it's been kind of a problem. They said we've really got to take a look at this. So now is the time, and you are the ones. This just came out this year. This is the UN's International Panel on Climate Change, 6th report. And this is very clear. There's no more beating around the bush. It's like every ton of CO2 emissions adds to global warming. It adds to the changing temperature on the earth. This is unequivocal. There is no maybe, there's no making it a political thing, making it for or against. It's what is happening, and it's what's gonna happen. So this graph is showing us how the black line is like what's already happened, and the temperature is rising, and we know that's associated with all kinds of terrible things happening, the ocean dying, source of our oxygen being ruined. I mean, it just goes on and on. We don't need to get into all that, but everything that emits carbon. So when knowing in your design what carbon emissions are associated is one way of looking at this. Just one way. So the pandemic has showed us how all this stuff is interconnected, and so we need to make some changes. And you'll get these slides. There's a whole bunch of links on here to different things. So what does it have to do with your design? So here's some models. So Planet, People, Profit. Has anybody seen this before? Yes, no, maybe? Familiar? No?
I haven't seen this before.
Me neither.
Okay.
No.
So what it is it's like we're looking at these spheres that we deal with. So there's the environmental sphere, the social society sphere, and the economic sphere. And the point where all of these intersect, we call sustainability. So that's the point where we want our designs to fit in. We want them to be economically available to everybody. We want them to be socially just, and we want them to not harm the earth. These are just different models. This kind of just says the same thing. This is another model which is a little different in that it's the thinking here is like without the earth, without the planet, without our home here, we don't have a society, we don't have an economy. So all of these things should fit inside of what's good for the planet. So this is more of an environmentally centric approach, which has some definite pluses, right? This is just to show you're not alone in this. This is the United Nations Goals for Sustainable Development. And this is for everybody. Everybody is modeling what they're doing after it. So we're engineers, so we're modeling our designs to meet these goals. And so even though you're an engineer and you're designing a table, what does your table have to do with goal number 1? No poverty. Well, I'm going to invite you to think about that, and I'll give you some ways that that's possible to think about that. So this is just more sustainable design, maximizing the good and limiting the bad. The respect. So these principles are from John McLennan, and he is a architect. He invented the green building kind of plan that's quite popular criteria for making a building sustainable. There are several different criteria for making buildings sustainable. His is one. But anyway, so respect for the wisdom of natural systems, and this is biomimicry. I will send you that video. the idea is that you look at nature and you see that nature has done everything that humans want to do. And nature does it without harming itself. Nature does it without polluting the planet. Nature flies, nature goes underwater, nature builds bone, muscle, structure out of materials without using harmful chemicals, without inventing things that harm the rest of nature. So that's a challenge, and Janine Benyus is the promoter of biomimicry. So like looking at nature, designing buildings that keep themselves clean because of this, the surface of the building is like a leaf or things like that. And then respect for people is the human vitality principle. And that's where you think about like what your design, how it's connected to people. Who are the people that made that stuff? Who are the people that got that stuff to you? Are they paid a living wage? You know, the raw materials that you're using, for example. Respect for place, and that is are the materials you're using in your table, are they taken from somewhere on the planet where they can't be regenerated or put back? Is the place damaged after those materials are taken out? Or are the people taking them out able to help that place regenerate? Cycle of life, 7 generations principles comes from Native American traditions, or actually all indigenous traditions have kind of this idea that you don't do something now that is going to in any way affect people 7 generations later. Like, in other words, will all those of your grandchildren, great, all those people still have the same benefits you do without losing any ability to provide for themselves. Energy and natural resources, conservation is about like everything has energy embodied in it. Everything you use, every material is created with energy somehow, or it's transportation, it's brought to you in some way. So that's what this principle is about. Like, how can you use materials that have the lowest embedded energy in them? And then respect for process is the holistic thinking principle. As engineers, we like to break things down into little bits, but really everything is, there's a system connected. Everything is connected in a system. And when you do one thing, it's going to affect something else somewhere else in the system. So these are just principles that can lead to you to thinking about the different, these different aspects. So these slides here, you can go through them later. They just ask, you know, the kind of questions that I just reviewed with you. They ask you these questions. How would nature do it? So I think I'll just kind of go through these. I kind of described them. And I talked a little about embodied energy. Embodied greenhouse gas, you can find for any material that you decide to use for your table, you can find information on the embodied carbon in that stuff. You can buy a door now and put it in your house, and there's somewhere, depending on the company, there's a manifest that says like how that door was made and what the carbon footprint of that thing is. So even if you don't have that kind of technology with your thing, you can think about it. Like, you know, a piece of wood, for example, you know, is carbon. That's stored carbon. And so thinking about the materials you use and how they got to you is important. Water is becoming an issue here. We got plenty of it last night, but still, how much water does it take to make that material? And then are chemicals involved? And then what about the humans that that got that material to you? So this is the US EPA has another whole set of principles. They are pretty much the same, but they're just stated differently. So I've included all of the principles here for you. I don't think I'll go through all these today, but they're just different people who have put forth different principles. I wanted to talk a little bit about life cycle thinking though, because that's an important one. And that's the idea that what happens, where do you get the materials for your table? What happens to those materials when the table is done? Like, are they going to go back to the earth, or can they be reused? Was your table made out of recycled materials in the first place? So that kind of thing. So the life cycle thinking is you're not just designing a table for right now, that pieces of that table came from somewhere, and when you're done with it, it's going to go somewhere. So where's it going to go? You know, if it's made out of plastic or something like that, like where is that? What's going to happen to it? Is it going to end up being buried in the landfill, or can you design something so that it has a more complete cycle? All right, so waste is another important one. Minimize depletion, but strive to prevent waste. So in nature, there is no waste. You know, the leaves are falling off the tree, and those leaves, you know, now they're not waste, they become enriching the soil. So nature has a cycle. So how can you prevent waste? How can you not have the parts of your table be wasted, or minimize the materials and have them cycle again? Okay, so right, this is an example of a life cycle analysis tool. And so it's just a way to think about things. So in life cycle analysis, you think about the inputs when you're making something, and then the outputs. You think about the inputs when you're using something, and the outputs. You think about the inputs and the outputs when its use is finished and you're renewing it. Okay. So I don't know, does anybody have any questions? Here's an example of life cycle analysis, inputs, outputs. So if you're making paper, you need trees, water, chemicals, energy, transportation. And then the outputs, you're going to have some wood waste, you're going to have wastewater, there's chemicals involved, there's carbon emissions, there could be air pollution, transportation. Okay, and that can happen when you make the paper, when you use the paper, or when you recycle the paper. So let's see what else we got here. I think here's another list of ways to think about things sustainably: is values thinking, systems thinking, and strategic thinking. These probably aren't going to be futures thinking as useful to you here, but they may be someday. Okay. And then here's some, have you ever seen The Story of Stuff, that movie? It's a really great 20-minute movie that you should watch if you're interested in sustainability. So that's basically what I have. Do we have time for questions, Joanne?
Yep. Yeah.
Is there a link to this online?
Yeah, I'll put it in Canvas.
Thanks.
I think there was something in Canvas. It might be there, but I couldn't get it. So I'm not sure. I couldn't see the file that was there. So I'll just switch this one out and make sure it's that one.
Okay.
But
Yeah,
somehow it wouldn't give me access.
What I have posted in the module is your presentation, Karen, from last time. So since it sounds like you've updated it.
Yeah,
so
I
I'll
updated
delete
it.
the other one, and why don't you just send me a link?
I can put it in
Either
there.
one.
I'll just put it in there.
Okay. All right. Thank
Okay.
you.
Other questions? What do you think?
You guys, when you buy something or build something, have you thought about all the items that Karen is mentioning to you?
I
Go
Oh,
ahead,
go
Ben.
ahead.
No,
Oh,
you're
okay.
good.
So when you were talking about like how much water it takes to produce something, so like are you just talking about like how much water is needed to manufacture the material, or if it's something like wood, how much water do the trees need to be able to develop to the point that they did, or some combination of those things?
Yeah, like it just, water is just a metric. Like when you see, I don't know if you've ever seen like a cheeseburger is like 600 gallons of water. And so what they're calculating there for your cheeseburger is like all the water it took to grow the grass, all the, or whatever the cow ate, all the feed, all the cow ate, all the water it took to keep the cow growing, all the water it took to slaughter the cow, all the water it took, to grow the wheat, to make the bun, to process the wheat, so it's just a way, quantifying it with an actual number isn't as important, I think, as just being aware that there are numbers. And if you look online, you might be able to find, resources if you care about water, or if you care about carbon. You can find resources that will tell you like the carbon footprint or the water footprint. Those are probably the words to use. You can find your own carbon footprint, your own water footprint, by answering some of these. They have online surveys or quizzes kind of thing where you can calculate, online calculators. Yeah.
Okay.
Does that answer your question?
Yeah, that makes sense. I was just double checking.
Okay, Gillian?
Yeah, I was just gonna mention something that I thought was really cool and interesting. And that is the idea behind mimicking what nature has already created, because it already does everything that we want to do, like you said, and looking and trying to learn from the systems in nature that are already in place and seeing if we can recreate those, because that's pretty much the best design we could probably come up with.
Yeah, I think so. Let me just give this 1 minute, 2 minute video here another try. No, it's not going to do it. Oh,
Want
well.
to send me do you have the YouTube link, Karen? Maybe I could post it. Would it work better? Is it because you're going?
Okay, I got it. Let me try it right
Oh,
here. I think this is
okay,
the right
great.
one. Let me try it just really quick. Share screen. I'll try this one more time. Okay.
The people who are learning about biology, they're reaching back to ancestors that are 3.8 billion years old. And when you look at the age of the Earth as a calendar year, and today is December 31st, just a few minutes before midnight, we got here 15 minutes ago. But our biological ancestors have been here since March of that year. And in that time, in that 3.8 billion years, life has learned to do amazing things. Life has learned to fly and circumnavigate the globe and live at the top of mountains, bottom of the ocean, lasso solar energy, light up the night, make miracle materials like our skin, horns, hair, brains. Life has done everything that we want to do, but without guzzling fossil fuels, without polluting the planet, without mortgaging its future. What better models could there possibly be? Life creates conditions conducive to life. And since we're not separate from that, we can do that too. But I think that we have to go back and ask the help of some of these biological ancestors. We can decide as a culture to listen to life, to echo what we hear. We can make the conscious choice to follow nature's lead in living our lives. The real benefit of a biomimetic life, of biomimicry, is that by learning from nature, instead of just learning about nature, we begin to feel a part of, rather than apart from, this genius that surrounds us.
worked. I'm so happy you got to see that. She's so eloquent in the way she states that. And that's really a key thing, is like feeling a part of nature, not apart from it. And when humans start to feel that way, when we start to feel like we are nature, then we will automatically not do things that threaten our future and the future of the planet.
Tony, you have a question?
Yeah, so you mentioned that, like for example, Native Americans took a different approach to how they did things. Is there like any, has this been started, like sort of been implemented into engineering, and has like, is there anything like in Cabrillo that,
Yes, I can give you a link. There's actually a Native American Scientists and Engineers Society,
oh wow.
which is like really exciting. And there's some really exciting stuff happening at Cabrillo too, in terms of an Indigenous Students Club. I don't know if you've heard about that. And I've been working today on planning an event that's going to happen in the spring, which is going to have a whole bunch of Indigenous people here at Cabrillo talking, telling us about their visions and their stories, and just really excited about that. But I will post that in the Canvas, the Native American Engineers and Scientists group, and they have a lot of resources that are really exciting. Yeah.
Awesome. Thank you, Karen.
Thanks for the question. Anybody else?
Oh, hey, how's it going?
Hey, Luis.
Yeah, I just wanted to say that this is an extremely interesting topic. I just wanted to say that it's also I've been reading a lot of articles about this, and it's something that's also inclined to be politically inclined to into topic. For example, I've read that monarch butterflies are, you know how they cycle through Mexico, right?
Mm-hmm.
So there's been actively and politically active people who tried to make this uprising and to help them be sustainably active in the environment. And there's been these instances of these people disappearing. And so I think it's an interesting topic that that through politics, sustainability could be an important and huge thing that could go wrong. So
Yeah.
I just felt like pointing that out.
Yeah, thank you. Yeah, it's really coming to the forefront now, and I think it's behind almost everything, every decision I make. And I know many people that hold the earth dear and feel connected to the natural world and connected to the humans and the other creatures on the planet, are paying more attention and taking more care. And engineers have a huge role in this process, because everything needs to be remade. We need to do everything differently. And so your creativity and your design skill in the future is going to be what makes that happen, along with everybody else.
Yes, correct. I think eventually, as we go into our careers, we'll see how the environment is affected with our designs and everything. So I think it's pretty cool.
Right. And also you mentioned being the political piece too. Sometimes we think, oh, as engineers, we just want our calculator. We just want to go in a corner and do our work and not consider the implications of things, the political and social implications. But we really do have to take, all of that into account for our work to be successful as engineers. So thank you for bringing that up. Anybody else?
I'll
All
throw
right,
a question
then.
out there.
Wait, Josh has
Hey,
a question.
Josh.
Okay, so how do you kind of be a more sustainable consumer on your end? So like obviously we're doing the table project and the easiest option is just to go down to the hardware store and buy some wood. It's probably not the most sustainable, but I don't even know where to start on the opposite, you know?
Yeah. So, yeah, I mean, wood is a good choice, I'd say, because wood is sustainable. Like redwood in this county is very sustainable. We have big trees harvest redwood sustainably. They have more redwood probably in their forest now than they had 20 or 30 years ago even, because they are harvesting the trees and opening up the forest in a way that, you know, makes redwood grow sustainably. So I'd say, you know, choosing local things. If you know anybody that has a garage full of like wood scraps, that's a good option too. Then maybe you don't have to buy wood. Come see me in the STEM center and tell me what kind of wood you need. I never throw away wood. I have all kinds of wood squirreled away. But you know, so there's things like, there's ways like that. So building, you know, there used to be a place where you could go and just buy like, you know, random doorknobs and junk and pieces like things like that you needed, hardware and things like that. But they're not around anymore. The dominant culture wants to sell us stuff, right? They want us to consume. So any way that you can circumvent that or mess with that culture, I think is, you know, makes me feel like I'm doing a little bit more of the right thing. But in our culture, we can't really live 100% sustainably because we just can't. It's just, we're just, as an American, we get a ton of carbon attributed to us just for being here. So, but being conscious, I'd say, and doing the best you can is good.
Thanks.
Okay, if nobody else has any questions, I gotta hop off and go on to my next thing, but
Okay.
I
Well,
really
thanks.
enjoyed. I'm in the STEM Center on Mondays and Fridays, like after your class. I'm there from 5 until 7:30. Oh, Mondays and Wednesdays from 5 to 7:30, and Fridays 3 to 5. Although I usually don't even close at 5. We usually hang out for a little bit. So come see me and
Yeah.
we'll talk sustainability.
Yeah. Karen, hang on a second.
Yeah.
As Karen mentioned at the beginning, she taught engineering 25 for 40 years. And she
No,
taught
40 semesters, only
40
20
semesters,
years.
I'm sorry. Right, sorry, 40 times. And she taught the AutoCAD portion. And Karen Groppi is the person who I listed on the announcement that's available if you need help in AutoCAD. And when she's in the STEM Center, she's taking questions from people if they come into the STEM Center physically, or if they're virtually logging into the STEM Center through the STEM's Zoom link. Okay, so you'll probably be meeting Karen again, especially if you'd like to get more support in AutoCAD. Okay, Karen, well, thanks so much for opening our eyes to the broad aspect of sustainability. And thanks.
Okay, thank you. Thanks for all listening.
Thank you, Karen.
All right, bye.
Bye. Okay, you guys, so what I'm going to do now is I'm going to show you, go back to our module for today. So I'm going to share my screen. And I'm going to our module, which is today, class 18. This is Karen's presentation that she made last time, and it is slightly different than what she did today. She updated it, so she'll post a new one. She also has information here on the life cycle, and I'd like to go through that. She kind of went a little quickly through it, but looking at the life cycle analysis. So there are 3 aspects. So see, this is part of her presentation. Hang on a second. So when you make something, when you use it, and then renew it, And she showed you the one slide about making the paper and all the things that are taken into, that are inputs in making the paper. And these are the outputs. The next slide, well, what about the use of paper? Well, the inputs, what are, in order to use paper, you need pencils, you need pens, you're going to use wood and plastic, you need printers and copiers and postal services. I know that Karen has really made it her life's work to really be as sustainable as she can. And she doesn't use paper anymore. Everything is she's using on the computer. And then what are outputs from paper? Newspapers, art, wastewater, chemicals, etc. And then the third stage here is, well, what do you do when you're finished with paper? You know, what are inputs? Well, we could use used paper. We're going to need water, chemicals, etc. Do we recycle paper? Does it go to the landfill? Does it go, uses wastewater? That's an output. So this whole, let me minimize this for a moment and go back to the initial. So here is some presentations and information on her. There's also some information on sustainability materials, that resource that she gave me last time. And then I made an overview page of sustainability criteria that you can choose what you want to use in terms of the class. And it is a summary of what her presentation was about in terms of respect and the green energy principles and the sustainable thinking. And here I'm going to go over this in a little bit. It's in our project, on our project assignment sheet. And then she talked about the UN making sustainable development goals. So she mentioned there's a number of people who have come together and come up with ways on how to be more sustainable. One is this Jason person, this, the green energy principle. Another one is sustainable thinking, and then the UN. Okay, I'm going to go back again. Go back to the module. And let's go back to the project itself. And the project is in class 16. And let's open up the design project, which I actually have open already. So I'm just gonna, it's right here. And I'm gonna open this up. And I'm gonna scroll down. And so here are the design specs that I suggested. Well, here are some of the materials. So materials proposed for use in the table shall be sustainable as possible, shall meet as many of the following as possible. So you could reuse material. You could use new material that's manufactured from recycled constituents. So if you went to a lumber store and bought wood that was processed using older pieces of wood, if it's locally produced, if it's rapidly renewable material, which is very interesting, the term used, basically it's natural material that is non-petroleum based, and it has a harvest cycle of under 10 years, which means when you use it within 10 years, that same material could regenerate itself. So if you could imagine a tree like bamboo is a rapidly renewable material, right? Bamboo is a natural material that grows prolifically, and you could reuse it. You use it and then it grows back within way less than 10 years. In fact, when I moved into the house in Santa Cruz a number of years ago, there was huge bamboo in the back of our house that was about 3 inches in diameter. And literally, I came here one day and a week later, those stalks had grown 3 feet. Amazing. Bamboo is great. Or if you're using recyclable material. And Karen says she has tons of wood in her house that you could have. So this is an example of some of the things you could use to be sustainable. Okay, let me go back to the module. I'm going to delete some of I just closed some of these pages. Okay. So, and I wanted to remind you also that really the focus of today's class is all about sustainability criteria. So if you look at the homework that we need to submit, design project submittal 2, it's basically a draft of your report and you're updating stages 1 to 3 based on my comments. And then you're adding sustainability criteria. So I'm going to open this up. So you'll see for the submittal 2, basically you're editing stages 1 to 3. Stage 1, problem statement, make sure you have the headings, make sure you put all the information that I suggested, and then read through all the sustainability class notes and make a bulleted list of the sustainability criteria that you have chosen for your design. Okay? Right now, we're just making a bulleted list. When we get towards the end of the project, you are going to detail each of the sustainability criteria in more detail. So if you want, you can detail it now, but for now, what is required is a bulleted list. And when is that due? That's due on October 29th. So I'm going to stop sharing for now. All right, so any questions yet? I'd like us to take another break. So let's take another break. Break time, return at 4:45 p.m. Okay, and I'll see you in a little bit. Actually, let's make it 50. I want to give you more than I only gave you a 10-minute break so far. Let's say 4:55. Okay, return at 4:55. So you have 15 minutes for a break, and I'll see you in a little bit. I'm going to take a break as well. So what you're going to be turning into me for submittal 2 is the reworked stage 1, 2, and 3, and an additional now adding the sustainability criteria that you want to use for your project. So stage 1, 2, and 3, and the sustainability criteria. And then you're going to turn that in, and then I'm going to look over it next weekend like I did this past weekend. I'll mark it all up. I'll submit it back to you. And then a week from today, we move on to stage 4, 5, and 6 on your project. So I want to kind of end at 5 in case some of you want to go get AutoCAD tutoring from Keith. So right now I'm going to share my screen, and the rest of the class now from 4:45 to 5:30 is really working on submittal 2, updated stages 1 to 3, and then add the sustainability criteria. I can meet one-on-one with any of you who have questions.